Hi, I'm Cynthia from Firebase. Today, I'm going to take you through the Firebase Web Frameworks Code Lab using the latest integration between Angular and Firebase, Angular Fire. In this Firebase Web Frameworks Code Lab, we're going to be building a travel blog where you can record the attractions and lodging that you had on your journey and then share them with your friends. All of this is made possible by Firebase using Firebase Authentication, Cloud Storage, Cloud Firestore, Cloud Functions, Hosting, and as well as Angular Fire, the latest integration between Angular and Firebase. Here's a demonstration of how the app would work. Login is powered by Google Auth, and the trips are being displayed on the screen at the moment. You can create a new journey and then add the stops that you had along the way. Give it a nice title and some notes to share with your friends. Due to the tight integration between Angular and Firebase, all changes are directly updated into the database without need of middleware or server-side rendering. Text content, such as the travel notes and titles, are stored in Cloud Firestore, whereas images are stored in Cloud Storage. They work seamlessly together under the hood of Angular Fire. As you can see, we have the Firebase Emulator suite, where we can test and view changes to our database, as well as our functions, authentication, and other storage before we deploy them to production. As we previously saw, that was the Firestore storing travel as well as stop data, whereas storage stores the image data, which can then be brought together by Cloud Functions or Angular Fire. This is a deployed example of the same app in production powered by Firebase Hosting. We'll choose a name as well as our account. And that's really all you need to do to create a project. While we're waiting, we can do an npm install to make sure that we're not missing anything from the packages. And since it's still waiting, we can first log into the Firebase console. Now that we're logged in, and it seems like the project is hosted, we can start adding assets. For example, Authentication and Cloud Firestore are useful ones that we'll be using today. We'll want to add a Google Authentication, just so we don't have to deal with authenticating emails and two-factor authentication. And it's simple as that. Then we can add Cloud Firestore to our account. And we'll begin in test mode because you don't want to do production right away. You can select a server closest to you. And now for storage. Storage excels at storing files such as images, videos, whereas Firestore excels at storing documents, especially nested ones. They both use security rules, which, as the name suggests, enhances security on what operations and what conditions can documents be read or accessed. And now it's time to add a web app in there. This is simply registering the app so that it can be hosted. We would then want to install Firebase and then keep track of our API keys. You'll want to store them somewhere safe. You'll want to keep them somewhere you can't lose. With the API keys in place, we can now initialize a Firebase project. Of course, we have to install the tools first. Then we want to add Angular Fire into... Oh, I mistyped. We'll want to add Angular Fire into our project. It's easy enough. You just select the features that you are using or you want to use, and it'll set everything up for you. That's the project we just created and the web app that we'll be hosting to. And that's it. Your app is integrated with Angular Fire. This is the project that we've just created. We want to make sure that we're using it so that we're deploying to the right address. Then we initialize other features in Firebase, such as emulators, and it's the same thing. Just click the features that you want to use. Firestore and storage, as previously mentioned, comes with Firestore with their own security rules. They also come with indexes, which are useful for querying. Firebase JSON and Angular JSON and everything within it is pre-generated, so you don't have to worry about wiring up everything on your own. Web frameworks can also detect your existing code bases, so really it lessens your work even more. And now we're adding emulators into our project. Emulators are a new-ish addition to Firebase, where it allows you to work in development mode locally without having to push everything to production. It gives you the safety and security to test everything out before you actually push. So let's start the emulators. And that is not how you spell emulators. As Emulator initializes, it also builds the Angular package. And as we can see, each emulator is on a different port. You can directly access them in a web UI. For example, Authentication is hosted on localhost 9099. Or you can directly view them all at port 4000. And we can see that the emulators that we selected are on, while the emulators that we did not select, like database, is not available. Since emulators mimic the behaviors in production, the deployment to production after testing on emulators is virtually seamless. Right, so now we have everything basically set up. What does our initial app look like? It looks like this. This is because we haven't implemented any of the functions. Let's start with login. So we have two empty functions. We will find that all the features we signed up for are automatically injected into the app modules TS for us. However, since we want to develop locally, we want to connect them to emulators instead of connecting them to production. So let's add a check here to check if the current environment is development or production, and then connect them to the emulators that are listed below. I just did that for Auth, and each other emulator is also the same. Let's do them together so we don't have to do them back and forth. And by defining them in app module, you can inject them anywhere as a dependency without needing to pass it down through parents and childs and parents and childs and parents and childs. It's super convenient. And each port is different for each type of emulator. And there we go. Right, so now let's add a sign-in page and start with authentication. We'll bind the login component with the sign-in path and then implement the login functions using Google-provided authentication. And now let's add the Google provider. Using the user function, we can get the current signed-in user's info or whether or not they're signed in at all. All of these functions are predefined so that we don't have to write them ourselves. We simply put the auth context as well as the provider in, and then I'll return the credentials and as well as whether or not the sign-in was a success. Forgot the din. For sign out, it's just as easy. Simply sign out of this auth, and then across the app, the auth state will change to signed out. And it's that simple. Now we pipe the auth state in as an async, and then if the user is signed in, we can display their names. If not, we'll simply redirect them back to the sign-in page. So similarly, with the login page, we're injecting the auth into the header component so we know the state of the user authentication. Similar with the login page, the header will now be able to display different elements based on the auth state. And now we have a nice login page. And after it gets the correct credentials, Firebase registers this user in their authentication storage. Now that we're done with authentication, let's start with Firestore. Let's implement the create travel function to add something into our Firestore database. But first, we'll need to know how Firestore works. In this app, most of the functions that are repeatedly used are in travel service. In that sense, you don't have to inject file storage, auth, several hundred times into several hundred different components. That was a lot to inject. We're going to keep the auth state, or so to say, the observable auth state in travel service. That way we don't have to inject auth and check for auth state a billion times over. Like now, we don't have to call the user function in header. So on to creating a new travel object. How things work in Firestore is that we have documents that hold collections and collections that hold documents. Think of them as array objects and objects in arrays. The root of it all is usually a collection. For example, we define a collection called travels, and then we add a travel object into the travel collection. But each stop is a collection in a travel object, which means that the travel object nests a collection called stop. So, for example, summer vacation travel holds a lakeside stop. Now let's try to do that through the code. We've defined travel objects like this, with end date, start date, whether or not you want to share with the public, your user ID, and the title. And stops include the top text of the blog, titles, images, and more. So we have the JSON object of travel data, but we'll want to put it into a document, which is nested inside a collection. So first we define the path of the collection. It's going to be a collection called travels. Now we want to add a doc into that collection. So the add doc takes the collection path as a parameter, and then travel data as the second parameter. This means that we're adding the travel data into the travels collection as a doc. And after we have the document in there, we want to create a collection of stops for that. We want to have a collection of stops for that document of travel. So we'll add a collection inside of that document. And so, moment of truth. Let's see if the button works. We'll call the function that we defined in travel service in the component. And if we did everything correctly, then clicking the button and therefore calling the function should create a travel object in Firestore. So, moment of truth. I think I may have mistyped. Oh, yeah. There we go. And clicking it doesn't seem to do anything, but behind the scenes, we can see that it populated our Firestore database. And that the user ID is the same as the one we used to create it. Now that we can create a travel object, let's try creating a stop object. A stop object exists within a collection of stops that exists within a travel object that exists within the travels collection. It sounds confusing, but it's really not. We simply have to define the correct path, such as travels collection, travel ID, the document ID, and then the stops, and then we get the address. And there, simple as that. We defined update data pretty much the same as add doc, except it's a different function. And for this particular function, it works for both travel and stop, because even though they're nested within each other, they're still both documents and they can be updated the same way. And of course, same thing with deleting. Get doc data and get collection data are a tiny bit more interesting. Essentially, what they're returning is not an object, and it's not actually returning data. It's returning an observable, which, whenever event is submitted, deletion, changes, it'll listen for those changes, and it'll notify your app directly. Same thing with collection. It seems confusing at first, but then you remember that collections is always an odd path and documents are always an even path. Really helps you remember. We'll leave the storage upload for now. and we'll get back to it later. But now that we have all these functions in travel service, we can have some more complicated components, such as editing or adding stops within a travel, or deleting them, or dragging them around. But first we need to resolve the compile errors. Actually, I don't think activated route will help here. Yeah. So we defined the array of observable travels, which are travels that belong to you yourself. And stop list is the stop collection of whatever travel that you happen to click upon. Obviously, this page, or so to say, this component is not suitable for editing the travel itself, but we have another page for that. This card is the same one that is displayed in the Firestore, and updating it manually or through the emulator should also update the display. So now let's try editing an object. Since we'll be editing each document directly, we want the document ID, which is the travel ID of the travel object. And now that I think of it, when you create a travel object, it should really redirect you to the edit page so you can add stops and make it more fulfilling. So let's add a router. See, when we add a new travel object now, it leads us straight to the edit page. we see that the edit page is a bit more complicated than the pure display pages. But really, it works the same way. We take the functions defined in travel service, and we listen for events that the child component sends. We take the travel ID from the params from the URL, and we listen for changes on that travel object. Since we have the travel ID, it's very easy to update the current travel. But stops is a bit more interesting, and that's why we defined child components to help with us. Making sure that the path is valid is very important. This is why you should always check the path as well as the reference exist before trying to update or delete it. Implementing the larger page functions is pretty straightforward. It also has two child components, editing the travel object itself and editing the list. Although both can be solved with a simple ng-list and async pipes, the stop list, or so to say collections, is a bit more interesting because it actually includes uploading images into storage. And storage works similarly to Firestore. It consists of folders and objects. But unlike Firestore, where collections are nested within documents and documents are nested within collections, it's pretty straightforward. It's just folders and items. But we do need to make sure that each path, or so to say, the full path of the object, is a unique string, which means that we tend to use user IDs, object IDs, and in combination with its own name. So in this case, user IDs in combination with travel IDs, in combination with stop IDs, in combination with its own name, to guarantee that it is a unique object. And unlike Firestore, whose reference can be used directly, storage is a bit more complicated. After you upload the object, you have to re-download the download URL in order to display the image in your website. So now we're trying to define the function that will be passed in so it can upload the images. And in any children components like this, they usually have an output of event emitters, which emits the partial of either stop or travel. And when they emits, it triggers the on-change of its parent component, which in turn triggers their own on-change, which in turn triggers travel service, and it leads right back to Firestore or storage or call functions, whichever service you have it bound with. So now we're trying to make sure we have the correct travel IDs and snapshot IDs. Stop IDs. And now our app is starting to resemble what it looked like earlier. So, similar with Firestore, you need to get the reference of the item that you're uploading. Once you get the reference, you can use the reference to upload the blob or file or image itself by bytes or by blob itself. And just so we can get the download URL right away, we want to be able to store it within Firestore. So we're just going to use the ref to get the URL to store it away immediately. So up with the function that we defined in travel service, we get the downloadable URL from the stored image right away. And if it didn't fail, or it was not an empty string, then we store it in our stop. That way it can be displayed on cards and later on maps. Fire also features another very useful service called Auth Guards. It essentially allows you to redirect users that don't meet a certain condition or meet a certain condition onto other pages. For example, right now it's redirecting everyone who is not logged in into the logged in page to keep My Travels and Edit page safe. And also it redirects people who are logged in to My Travels page. Since they are self-defined, you can define the functions however you like to whatever path you like to trigger any function you like. It's not set in stone, and it's a very flexible route guard. And just like that. So last but not least, we want to deploy our app into Firebase hosting. That can be simply done through the console with just a line of Firebase deploy. And there it is. We can see the project deployment at the project console, or you can directly view the app at the hosting URL. For example, we can see that it was deployed and a deployment history. And then we can check out the app that is hosted by Firebase. Due to time constraints, we couldn't explore too much about security rules or functions, but if you'd like to see how your travel blog looks on a Google map, please check out the optional steps of this collab, as well as other Firebase workshops exploring these topics. Thank you for watching. Please stay tuned for news releases regarding Firebase web frameworks, and I hope you join the rest of Google I/O.